This is a Rubik's Cube. It's also a great example for group theory. But before we start talking about that, what exactly is group theory? Group theory has to do with math and abstract algebra. It studies the algebraic structures known as groups. A group is a particular set of elements that when an operation is performed on two of the elements, it results in a third element of the group and meets four axioms or rules. A Rubik's Cube meets the guidelines to be considered a group. In the Rubik's Cube group, the elements are the about 43 quintillion possible permutations it has. The operation done to the group is turning the faces. Here's one of the 43 quintillion, and here's another, and here's another. Axiom number 1, or rule number 1, says that the set of elements must have closure. This means that there's a predefined list of actions that can never change. The moves that can be performed on a Rubik's Cube are examples of the predefined actions. Here we have a group with 4 elements. If you were to rotate the cube in any of the pictures by a multiple of 90 degrees, you would notice that you would get another element of the group. By applying this to the whole cube, there are much more elements, which opens up many more possibilities. Axiom number 2 states that the group must have associativity. This means that you could put parentheses wherever you want in the group operation and it would be equivalent to the same operation, but with parentheses in a different place. By using numbers, we can see that if there was the operation 2 plus 3 plus 2 and we put parentheses around the last two numbers, it would still be equivalent to 2 plus 3 plus 2 with parentheses around the first two numbers. Both of these are equal to 7. The third axiom is identity. There's an identity element in the set that keeps the set unchanged. If I do the moves R and U and then don't turn anything or rotate the cube in my hands, the cube stays in the same position it is until I move it again. With numbers, the identity property is that when you add 0 to any number, the number's value does not increase or decrease. It just stays the same. For example, 1 plus 0 equals 1. The final axiom is inverse. There must be an inverse for each element of the set. With numbers, you can add 1 plus 1, and the inverse would be 1 minus 1. With the Rubik's Cube, you can inverse the moves. So if you did the moves R, U, F, the inverse would be taking that set of letters and reversing them, and then also having them be counterclockwise moves. So I would do... This will get you back to where you started. Now we know the 4 axioms a set of elements must follow in order to be a group. There's closure, which means group operations are restricted to group elements only. Associativity, which means that you could put parentheses wherever you want in the equation and it would still be equivalent. Identity, which is the element in the set that keeps the set unchanged. And then there's the axiom that states there must be an inverse for each element of the set. So when you see a Rubik's Cube, don't think of it as a seemingly impossible puzzle. Think of it as a group, an organized one.